Your SCA tools can find thousands of vulnerabilities in minutes, but they won't help you fix them. And that puts you in a bad spot. You know risks exist, but you can't fix them quickly enough. And that leaves you and your company in a place of negligence. Let's dive in. Now, if you're a CISO or a security leader at a company that ships a software product, this is for you. And if that's you, there's a good chance that you've either stood up a supply chain security program or you've been asked to do so. And if you've been down that road already, you already know that the tools are the easy part. The hard part is everything that comes after. So I want to walk you through the 3 biggest problems I see so you know what you're up against. And in the next video, I'll follow up with the solutions. Let me set the stage first. Software supply chain attacks are not slowing down. If anything, they're accelerating. And the Shai Hulud campaign is a good recent example. So this was a self-replicating worm that targeted the NPM ecosystem, which is the largest JavaScript package registry in the world. The first wave hit in September 2025 and compromised over 500 packages. Then a second wave hit in November 2025. Within hours, it had compromised over 700 NPM packages and created more than 27,000 malicious GitHub repositories. And this was such a big deal that the CISA issued a formal alert. The worm harvested credentials, API keys, and cloud service tokens, and it used stolen GitHub access tokens to spread itself automatically. That's the world we're operating in. And if you're running a product company, your engineering teams are pulling in open source packages every single day. So the question is not whether you need a supply chain security program. The question is whether your program can actually keep up. And in my experience, most cannot. Here's why. The core issue is that finding vulnerabilities in your dependencies is the easy part. SCA tools, software composition analysis tools, are really just doing one thing. They look at a package manifest in your repository, the file that lists all your dependencies and their versions. Then they compare those package names and versions against a database of known CVEs. That's it. It's a lookup. And because it's just a lookup, this is really commodity work. Now, they usually couple the lookup with a bunch of fancy dashboards, but you don't need to spend 6 figures on an enterprise SCA tool to do this well. Google's OSV scanner is open source, it's free, and it does an excellent job. It supports most major languages and package managers and is backed by the OSV vulnerability database, which is one of the most comprehensive out there. I actually teach how to integrate OSV scanner into your CI/CD pipelines in my DevSecOps Pro course if you want to see that in action. But here's the point. The scanning part is solved. You can find these vulnerabilities easily. The problem is what happens next. The second problem is that most of what your SCA tool reports is theoretical risk. Let me explain what I mean by that. When a vulnerability gets a CVSS score, that score represents a high watermark. It's the worst case scenario. If everything aligns perfectly for the attacker, this is how bad it could be. But in your environment, everything almost never aligns perfectly. So what happens is your SCA tool comes back and says you have something like 5,000 critical and high vulnerabilities across your code base. And your developers rightfully push back. They say, if we really have 5,000 critical vulnerabilities, why haven't we been breached yet? And intuitively, they're right. Those risk scores are inflated. Not wrong exactly, but inflated for your specific situation. Now, many SCA vendors have recognized this problem, and their answer is reachability analysis. The idea is to use common techniques like static analysis to trace whether the vulnerable function in a dependency is actually reachable from the public internet. And that is valuable. If your application doesn't have a viable path to that vulnerable package, the risk is much lower. But reachability is only part of the equation. You also need to know things like, is the vulnerable package actually used, and are you using it in a vulnerable way? For example, I once had a critical risk vulnerability for a Python OpenSSH package. Now, when I looked into the vulnerability, I realized that it was only really exploitable if you were using it as a listening SSH server. So I searched through our code base and quickly confirmed that we were only using that package for outbound SFTP file transfers. Technically, it was a critical risk, but only if we actually decided to spin up an SSH server in our code. Reachability alone does not answer those questions. What we really need are tools that can accurately assess risk in context, not just report a generic CVSS number and leave it to the developers to figure out. The third problem is the one that really trips people up. On the surface, fixing a dependency vulnerability looks trivial. In most cases, it's a single line change. You bump a version number in your package manifest, done. Except it's not done. Now here's what most people outside of engineering don't fully appreciate. Many of these packages are maintained by one person, sometimes 2, or a small team. They're working on it nights and weekends. They don't have a large testing function or the resources to do so. So it stands to reason they're not testing against your environment. They're not testing against your configuration. They're releasing updates based on their own priorities and their own test coverage, and that matters because of how versioning works. Most open source packages follow a convention called semantic versioning. A patch release, like going from 2.1.0 to 2.1.1, is supposed to be a bug fix only. No behavior changes. A minor release, like going from 2.1.0 to 2.2.0, adds new functionality, but it's supposed to be backward compatible. A major release, like going from 2.0 to 3.0, can include breaking changes. And that means something that worked before might not work after the upgrade. Now here's the catch. Semantic versioning is a convention, not a guarantee. Breaking changes can and do slip into minor and even patch releases. So when your SCA tool tells a developer to upgrade a package to fix a vulnerability, what the developer hears is risk, operational risk. They have to pull in the new version, run their tests, manually check for behavior changes, and hope that nothing breaks in production. Multiply that by hundreds or thousands of vulnerabilities, and you start to understand why developers are not racing to fix these. It's not laziness, it's a rational response to real risk. So here's what typically happens in practice. These vulnerabilities linger for a long time. I've seen organizations sit on known critical vulnerabilities for months, sometimes years. Not because they don't care, but because the cost of fixing them, the testing, the risk of breaking changes, the developer time, it all adds up. And when every fix carries its own risk, it's hard to justify the effort, especially when the vulnerability is theoretical in the first place. That's the cycle. Your SCA tool finds thousands of issues. Most of them are inflated. The ones that are real are risky to fix, or they're buried beneath a pile of false positives, and so they sit there. Okay, so let me bring this all together. Problem 1, finding vulnerabilities is easy. It's commodity work. You don't need expensive tools for this. Problem 2, the findings are mostly theoretical. CVSS scores are worst case, and reachability analysis only gets you part of the way there. Problem 3, the fixes look simple, but carry real risk, operational risk. Breaking changes, under-maintained packages, and the sheer volume of findings makes remediation a grind. So the result is that supply chain vulnerabilities accumulate faster than teams can address them, and that's the problem that's worth solving. So next week, I'm going to walk you through practical solutions to these problems. If you don't want to miss that, make sure you're subscribed. I'm also writing about this in my newsletter, the Product Security Playbook, and I'll drop a link to that in the video notes. All right, thanks for watching. I'll see you in the next one.